Alright, so let's say you have a rectangular object and you want to find the density of it. And if I give you, the length, the width, and the height, and the mass, this problem is pretty easy, right? Because you just multiply length, width, and height. That gives you your volume. And then density is the mass divided by the volume, and you're done. So that's not what this video is about. This video is about that occasion when the object isn't a nice rectangle. So let's say the object is maybe, I don't know, some kind of a rock or something, and it's got this weird shape. So how do you find the volume of that? Well, I mean, you can't measure length, width, and height. I mean, you could, but there's all this empty space around here, so that would not be adequate. So we need to find, we need to find some other way to get the volume of this object. So what we can do is we can take this object and we can throw it in some water. So if you have a graduated cylinder, let's say it's got a volume original of 20 milliliters, so we'll call that, VO, the volume original. And so let's say once you throw this rock in, let's say the water rises up to a volume of, how about we say it's a volume of 25 milliliters. So we'll call that VF. So what we need here, to figure out the volume of the rock, the actual size of the rock, we just take the change in volume, and that's VF minus VO. So 25 milliliters minus 20 milliliters is 5 milliliters. So this is the volume of our rock, and I gave you the mass. So now we can just do our density problem. D equals M divided by V. So we've got 10 grams divided by a volume of 5 milliliters. That gives us a density of 2 grams per milliliter. So that's how you solve a density problem with water displacement method.